Okay, lesson 3, area and perimeter with polynomials. So it's just quick pages. Now we're going to take our multiplying and our adding of polynomial skills that we talked about earlier, and we're going to use them to solve area and perimeter problems. Now, we can use our knowledge of polynomial operations to write expressions for the area and perimeter shapes. Remember, perimeter is the length around the outline of a shape, so we would add up the outer lengths. So perimeter of a rectangle is 2 lengths plus 2 widths. A square would be 4 times the side. Area, however, is the space occupied by a flat shape. So it's the space occupied by a flat shape. It's the surface, and it's the number of unit squares that cover that surface of that closed figure. Now, area of rectangles, length times width. Area of a square is side squared. So remember those kinds of things. Generally speaking, when we're talking area, we're talking about 2D as opposed to 3D. 3D, we'd be talking about volume. Okay, so let's see how we can use our polynomial skills to solve area and perimeter problems. Find and simplify an expression for the area and perimeter of each diagram. So first, we're going to find the perimeter. Well, we have here, given that one side is x plus 3 and they're all the same thing, same side, the perimeter of a square is 4 times the side. We've got that up here. This should actually say perimeter square. Oops, that's an error in the booklet. So hopefully we've noted that. Excuse me. Yeah. Okay. So if the perimeter is 4 times the side, we take 4 times x plus 3. Now, all we would have to do is use our rules for distribution to make sure that we multiply within that bracket. So that would be 4x plus 12. And that would be our answer for perimeter. 2, we're going to find the area. Okay. Now remember from up here, the area of a square is side squared. So area is equal to side squared. So our side is x plus 3. We're going to square it. Now, you're going to want to write it out, and then you're going to FOIL, right? So remembering our FOIL rules, first, outer, inner, last. So when we FOIL that, we're going to get x squared plus 3x plus 3x plus 9. We're going to combine these like terms, 3x plus 3x. We're going to get x squared plus 6x plus 9. And that would be our expression for area. So we've just used some of our skills there that we learned to find those perimeter and there's the area of that square. Now, here we have something a little more complicated. So we would want to break it into 2 pieces. Okay, so I have 2 pieces here. This whole length here is 2x minus 1, but this side here is x. So that tells me that this side is 2x minus 1 minus x. For this side here, let's see what that is. 2x minus 1 minus x equals x minus 1. And that would mean that this piece here, oh, sorry, that's not right. That side is x. This side is x minus 1. Sorry, my mistake. This side would be x. Just making sure that those two have to add up to that total distance, right? So we have 2 pieces. We have this one here, 1, and then we have 2. So first thing we're going to do is we're going to find perimeter. This would be like a normal rectangle if these sides were expanded out, right? And those are the same lengths. So we can just use our rules for adding the sides up. However, we could also do it like so. This side here would be the x minus 1. This side here would be 3x plus 4 minus x, so it would be 2x plus 4. Okay, so for perimeter, we're just going to add up all the sides. So P is equal to, let's start 2x minus 1 plus 3x plus 4 plus x plus 2x plus 4. I'm just going around, plus x minus 1 plus x. Now I add all those up. I'm going to combine my like terms. I have 2x plus 3x is 5x, plus another x is 6x, plus another 2x is 8x, plus another x is 9x, plus another x is 10x. Better double check that. And then I have negative 1 plus 4 is 3, plus another 4 is 7, minus another 1 is 6. So plus 6 for my perimeter. There's a number of different ways you can do that one, so you just kind of want to be careful. Now for area, find area, this is where you need to look at those two different blocks, right? For the block 1, it's going to be length times width, which is equal to x minus 1 times x. So I distribute, and I'll get x squared minus x for that one block. Now I have to do the other block, right? And I'm going to add them. So it also is length times width. So the length for that one is 3x plus 4, and the width is x. So again, I'm going to have to distribute when I multiply. So I'm going to get 3x squared plus 4x. So that's my area for that one. So I'm going to want to get my total area, which will equal x squared minus x plus 3x squared plus 4x. So I'm going to add all those. X squared and 3x squared is 4x squared minus x, and 4x is plus 3x. So that would be my total area. So there's a little bit of jimmying around, taking a look at the shape, trying to figure out what all of its sides are. Okay. The length of a rectangle is 3a plus 11. So 3a plus 11, and its width is 4b plus 18. What's the perimeter? And then once we get the perimeter as a polynomial, we want to evaluate it. So we're going to do some substitution. So first, as a polynomial, so it's going to be 2 lengths plus 2 widths. 2 lengths is 2 times 3a plus 11. 2 widths is 2 times 4b plus 18. So with both of those, I'm going to have to distribute, right? So when I distribute, I'll get 6a plus 22 plus 8b plus 2 times 18 is 36. And then I'll combine my like terms. I'm also going to order these, but alphabetically. 22 plus 36 is 58. Now that's step 1. Step 2, we want to evaluate the perimeter. If A is 2 and B is 3. So I take my statement here And I'm going to substitute in 6 times 2, because A is 2, and 8 times 3, because B is 3, plus 58. 6 times 2 is 12. Oops, just a second, 12. 8 times 3 is 24, plus 58. And then I add those all up, 12 plus 24 plus 58. I'm going to double check this with my calculator. I think it's 94, but I want to be sure. 12 plus 24 plus 58 equals 94 units. Okay, so evaluation, you're just going to substitute in and solve. Okay. Now for question 3, the big thing is that you're going to find the area of the shaded region. So what you have to do is you have to subtract. So you've got 2 rectangles. You've got a big one and a little one. You're going to take the big one and subtract the little one, right? So A of the shaded equals A of the total minus A of the unshaded. Okay, so area of the total will be length times width. So that will be x minus 4 times 3x plus 2. We're going to use FOIL. I like FOIL. I like tricks, right? Whenever math has tricks. So first, outer, inner, last. So we're going to get 3x squared plus 2x minus 12x minus 8, which is 3x squared minus 10x minus 8. So that's our area of the total, the big one. Then I'm going to do the area of the unshaded. Unshaded, it's also length times width, and it will be 2x times x plus 1. Okay, so when we do that, distribute, okay, so we get 2x squared plus 2x, okay. Now we're going to do our subtracting to get our area of the shaded. So area of the shaded equals 3x squared minus 10x minus 18 minus 2x squared plus 2x. Now, big thing is we need to distribute that negative sign. So if we expand these brackets, 3x squared minus 10x minus 18 minus 2x squared minus 2x. We need to get those negative signs correct to do this, okay? Now we're going to combine our like terms. So I have an x squared there and an x squared there. I have an x here and an x there. And my little old 18 is all by itself. 3x squared minus 2x squared is just x squared. Minus 10x minus 2x is minus 12x. And then I have minus 18. So this would be my area of the shaded section. Okay, so it's basically these area and perimeter questions are a way to apply the skills that we've learned in terms of both multiplying and adding and subtracting polynomials. There's no division yet. That's coming when we get into